Hello, my name is Jill Alty, and I am currently an assistant professor of chemistry at Stony Brook University. I'm really thankful to have this position, largely thanks to the Beckman Foundation for taking a chance on me. My group is at the interface of chemical biology, polymer synthesis, and organic methodology, and we're looking at how we can leverage polymer design to manipulate probiotic populations. Like Dr. Beckman, I consider myself to be a little bit of an inventor, more of a molecular inventor. I like to design new polymers that can have interesting biological function. So, Dr. Beckman invented the pH meter. This is extremely useful. We use it all the time in our laboratory. You can sort of think of probiotic bacteria also as a pH meter. They like to thrive in mildly acidic conditions, which we only know about because of Arnold Beckman's invention. I was a 2022 Arnold O. Beckman Postdoctoral Fellow in Laura Kiesling's group at MIT. I was able to be a fellow in her group for 3 years, looking at how we can design polymers as mucin mimics. So mucus is an essential hydrogel. Mostly it houses our microbiome. So we have more bacterial cells in our bodies than human cells. And mucus is discerning which bacteria do we cultivate and encourage to grow, and which bacteria do we inhibit or alter their virulence, such as pathogens. Some of the bacteria that you want to boost in your microbiome are probiotics. So these are bacteria that have a beneficial health effect to the host. This could be like reducing inflammation, or that they can push out or reduce pathogenic populations. So we designed mucin mimics. These are polymers that also have sugars, just like mucus has sugars. So these polymers were decorated with singular glycans, another word for sugars, and we were able to then dissect, okay, which sugar is responsible for the interaction with the probiotic, which is something you can't do with mucus biologically. So we were able to tell of 3 different probiotic populations, L. reuteri, L. plantarum, and L. fermentum, which sugar was their preference as a nutrient source or as a binding site. We could then leverage this information to make better retention strategies for probiotics. So we generated a pseudomucosa that was a mucus that was bound to the surface of a plate, and then added our probiotic bacteria in, and then added our synthetic mucin. And we saw with the synthetic mucin additive that the probiotic bacteria held tighter to the pseudomucosa and increased their populations, so they used these as nutrient sources. The second project I worked on in my postdoctoral fellowship was how can we change the morphology of the polymers, and does that impact how the bacteria engage with them? So you can think about, well, if the polymer is globular in morphology, those sugars that are of interest for nutrients and sites for adhesion are not available. And so they cannot provide that function to the probiotic cells. However, if the polymers are nice and extended, now we have access to all of those glycans for those enzymes to cleave it, or for surface reception of those identities. So we were able to develop prebiotics, essentially, from probiotics and polymers. The last thing that I'd love to highlight from the Beckman Foundation was that they were able to support me in a conference support fund. They were able to do this twice, which I'm very thankful for. The first was when I was chair of the Polymer Gordon Research Seminar. This was originally slated for 2021 and actually happened in 2023. They were also able to support me again as we developed a new conference of the Polymer Women Empowerment and Research Conference, largely modeled off of EWOC, which is an organic chemistry version of this conference. And we were able to thereby highlight women and gender minorities who are investigating polymer research. This was a really awesome 1.5 day conference that we not only got Beckman support from, but we got Beckman involvement as Katrina Bryant was able to attend and share with our community how to apply to the Beckman Postdoctoral Fellowship, the BYI, as well as the Chemical Instrumentation Fellowship. So I'm very grateful to the Beckman Fellowship for these opportunities and am very grateful for their support over the years. Thank you.